Hi, it's Karen Hudson. I'm going to work with you today on section 10.2, continuing in module 10. We're going to work today on product and quotient rules for radicals. First, let's start off with the product rule. For any non-negative real numbers x and y, we know that the nth root of x times the nth root of y is equal to the nth root of x times y. Notice these are all like indexes. We keep the index and then we just multiply what's underneath the radical together. So let's use that rule to do example 1. The square root of 3 times the square root of 5. Notice that these are both square roots. I don't need to write the little index on a square root. These are square roots, and I can find out that the square root of 3 times the square root of 5, I'll need to multiply the 3 times 5. 3 times 5 is 15, so the square root of 3 times the square root of 5 is the square root of 15. Going on with example 2, the cube root of 4 times the cube root of 7 is the cube root of, notice these are like indexes, like radicals, so I can multiply them together. I'll need to multiply the 4 times the 7 together and get 28. The cube root of 4 times the cube root of 7 is the cube root of 28. Example 3, the square root of 17 times the square root of 2 would be the square root of 17 times 2, which is 34. The square root of 17 times the square root of 2 is the square root of 34. Now when I start on this last example, I'm going to notice immediately that one of them is a cube root and one of them is a square root, and these are unlike indexes, and we're not going to do this type. This type can be done by getting a common denominator, but this is more complicated than we want to get in intermediate algebra. Okay, before going any further, I want to think about the perfect squares and the perfect cubes. Know that 1 squared is 1, and that 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 squared is 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. And 10 squared is 100. 1 cubed is 1 times 1 times 1, which would be 1. 2 cubed is 2 times 2 times 2, which would be 8. 3 times 3 times 3, 3 times 3 is 9, times 3 is 27. 4 cubed is 64. 5 cubed is 125, and so on to 10 cubed, which is 1,000. We'll probably not use 6 cubed through 9 cubed very often. Now, keeping this in mind, and you might want to copy these down, this will help us to do the next few problems. I'm going to simplify the square root of 50. So I'm going to think about those squares. This is a square root, so I'm going to think about the squares. 1 squared is 1, 4, 9, 16, 25, 36, 49, and I'm looking for a perfect square, the largest one, I hope, that will go into 50. If you don't get the largest one the first time, then you'll just have to simplify it again. 25 will go into 50, so I'm going to break the square root of 50 down into the square root of 25 times the square root of 2. And then the square root of 25 will break down into 5 times the square root of 2. This is as far as I want to break this down. The square root of 50 is the same as 5 square roots of 2. Now I'm breaking down this cube root. I think I have miscopied this. I think this should have been the cube root of 81 instead of the cube root of 18. And the reason why I think this is because 1 cubed is 1, and 2 cubed is 8, and 3 cubed is 27, and none of those are going to divide into 18. I think I meant to use the cube root of 81. The cube root of 81, I believe, is divisible by 27. I'm going to check it out and see. 81 divided by 27 is 3. So I'm going to drag that over there so I can use it. So I'm going to change the cube root of 81 into the cube root of 27 times the cube root of 3. And then the cube root of 27 will break down. If I need to break down the cube root of 27 and I'm not clear on what it is, 27 raised to the 1/3 power is how I break that down, if you recall, and that is 3. The cube root of 27 is 3, so my final answer here will be 3 cube roots of 3. Continuing on with example 1, multiply and simplify. Multiply and simplify, I had covered up part of that. The square root of 10 times the square root of 18 is the square root of 180. Now this 180, the square root of 180, is going to need to be simplified. So I'm going back and thinking about my square roots. Let's see, 1, 2 squared is 4, 9, 16, 25, 36, etc., etc. That's 36. Now, when I'm thinking about the cubes, let me pull out my calculator. The squares, 180, let's see, is it divisible by 25? I don't think so. No, that doesn't come out even. Let's try 180 divided by 36. And that comes out even. So I'm going to drag it down here. I don't want to use that one. It didn't come out even. But the square root of 180 is the square root of 36 times the square root of 5. Then I can break down the square root of 36 into 6 square roots of 5, and I will be finished with that problem. The square root of 3 times the square root of 15, I'll need to 3 square roots of 15 times 7 square roots of 10, I'll need to multiply the 3 times 7 and get 21, and the square root of 15 times the square root of 10 would give me the square root of 150. I'm still thinking of my perfect squares. Let's see, 1, 4, 9, 16, 25, 36, 49. I think 25 is the one that I want. Let's get the calculator and check it out. 150 divided by 25 is equal to 6. That is one that I can use. I'll put it right here so that I will have 21, and the square root of 150 is the same as the square root of 25 times the square root of 6. So now I have 21. The square root of 25 is 5 times the square root of 6, which will turn into 21 times 5 is 105 square roots of 6. Okay, let's look at this story problem. This is just an estimation of the area. We want to estimate the area of the rectangle with length equal to 2 square roots of 26 and width equals to the square root of 50 inches. So we know that area is equal to length times width, or the area is equal to 2 square root of 26. Now we're trying to estimate this, so I'm going to think about my perfect squares. 1, 2, 4, 16, 25, 36, 49. That's enough of them. The closest perfect square to 26 is 25. So I'm going to use the square root of 25 instead of the square root of 26. I'm going to write this down as 2 square roots of 25 times, and the closest perfect square to 50 is 49, so I'm going to use the square root of 49 instead of the square root of 50. And then I will have 2 times the square root of 25, which is 5, times the square root of 49, which is 7. 2 times 5 is 10, times 7 would be 70 inches squared. Okay, let's go on with the quotient rule. The quotient rule for any non-negative real numbers x and y, the nth root of x divided by y is the same as the nth root of x divided by the nth root of y. So we can split up a fraction and write it as separate fractions. So that's what I'm going to do in example 1. I'm going to split this fraction into separate fractions. I will have the negative the square root of 5 over 49 will equal to negative the square root of 5 over the square root of 49. I'm going to split this into separate radicals. Now, the square root of 5 will not break down, so I will have this negative the square root of 5 in the numerator, but the square root of 49 will change to 7, so I will have 7 in the denominator. Negative the square root of 5 over 7. This one is already split into separate radicals. Example 2, I have the cube root of 27 over the cube root of 8. I know that the cube root of 27 is 3. If I don't know it, I can use my calculator. The cube root of 8 is 2, so this example 2 will give us a result of 3/2. The square root of 50, I can divide 2 into 50. I can change that back into a single fraction. The square root of 50 divided by the square root of 2 is the square root of 25, and the square root of 25 is equal to 5. This concludes the video on section 10.2. I'll need you to do your homework on section 10.2, the quiz on section 10.2. This is Jo Karen Hudson. Thank you and have a great day.